Welcome back to Maths with Mrs. J. We've just done a video on deriving differentiation from first principles, how we get that formula. I just wanted to remind you before we do some examples that normally speaking, you will not be using this version to differentiate unless you are asked to do so. This clearly is a much more long-winded way of doing it than using the various rules that we're about to use in future videos. However, it is important that you know how to use this rule. Probably the most basic one, and pretty much everyone will start with this one, is f of x is x squared. Do this from first principles to find what f dash x is. All right, well, let's start with our rule. F dash x is the limit as h tends towards 0 of f of x plus h minus f of x all over h. You should learn that rule. Hopefully you'll do enough practice questions that the rule will automatically be remembered by you anyway. All right. Limit as h tends towards 0. We haven't calculated the limit yet, so we still have to write limit as h tends towards 0. Well, we know that f of x is x squared, so that's okay. We can pop that in there. We know that h is h. X plus h all squared will be our f of x plus h. If f of x is x squared, f of anything is that thing squared. All right. Now what we're going to do is some expansion. Please be very careful expanding a perfect square. Do not forget your middle term. So we're going to get x squared plus our 2xh plus h squared minus our x squared all over h. So just bear in mind those three terms there come from this here. All right, let's get a different colour and do some cancelling. All right, the x squareds are going to go, aren't they? X squared minus x squared, gone. All right, now what we can do is we can take out a common factor of h out of the numerator. Why do we do that? Well, we do that because if we were to try and sub in h as 0, you're going to get 0 over 0. And hopefully by now you've learned enough about limits to know that that's not going to work. So the best way to deal with a situation like that is to try, if you can, to take out a common factor and cancel, and then you can hopefully substitute in your h equals 0. Now, we are allowed to cancel here because we're just taking the limit as h tends towards 0. We're not saying h is ever actually going to be equal 0. We're taking the limit. Now, this is where things get a little bit contradictory, but it's not actually contradictory. Once you've done that, now you can actually, because we're just finding the limit of this, we're now finding the limit of 2x plus h as h tends towards 0. You can actually calculate that limit by subbing in h as 0. So your limit here is going to be, well, if you put in h equals 0, you're just going to be left with 2x. So it sounds a bit contradictory, but it's actually not. We're calculating the limit. So we found that if f of x is x squared, then f dash x is 2x. Bear that one in mind. Let's go on to our next screen and try a new one. This one is a fair bit more complicated, and this is probably about as hard as you would get as far as differentiating from first principles is concerned. Certainly you'll get harder ones to differentiate by rule. In order to do this, we're going to need to know how to expand a cubic. Just a little reminder here, I've got it down the bottom of the page. A plus b all cubed is a cubed plus 3a squared b plus 3ab squared plus b cubed. So therefore, when we put in our x plus h all cubed, we're going to get x cubed plus 3x squared h plus 3x squared plus h cubed. So just bear that one in mind. All right, let's write down our rule. So f dash x is the limit as h tends towards 0 of f of x plus h minus f of x over h. Remember, that was the limit of the gradient of the chord as those two points on the curve were getting infinitely close. All right, keep writing limit because we haven't calculated it yet. F of x plus h is going to be this function, but with x plus h subbed in. So we're going to get x plus h all cubed plus 2 lots of x plus h minus 7. Well, 7 is 7 regardless. I'm actually going to use some extra brackets here just to ensure that we're careful. So we're going to subtract, just do this. We're going to be subtracting out f of x, which is x cubed plus 2x minus 7, and all of that is over h. Okay, all right, expanding. X plus h all cubed, having a look down here if we need to, x cubed plus 3x squared h plus 3xh squared plus h cubed, that's this part, plus our 2x plus our 2h minus 7. Now, just be careful, we're subtracting all of these things. So we'll have minus x cubed minus 2x and then plus a 7. Be a little bit careful there, all over h. Again, let's do some cancelling. We had an x cubed and then we took away an x cubed. We had a 2x and we took away a 2x. We had a minus 7 and then we added 7. So all of those things are going to go. All right, let's proceed. Now, similarly to on the previous page, if you were to sub in h equals 0, you're going to get 0 on 0. So this is one of those many limit examples where it is helpful to take out a common factor. So we're going to get 3x squared plus 3xh plus h squared plus 2. Let's just check. Yep. That's all good, all over h. Now, we are allowed to cancel those h's because we're just taking the limit. We're not saying h is actually equal 0. We're saying h is getting infinitely close to 0. Now we can, it's okay to work out the limit of this by subbing in h as 0. Now that term's going to go, that term's going to go, and we're going to be left with 3x squared plus 2. So we found here that if f of x is x cubed plus 2x minus 7, then f dash x is 3x squared plus 2. We're going to start learning some rules that will save us having to do all this in future videos, but do a few practices of these because it is an important skill to have.